elc128 18. Alright, how many timers should a standard output with a specific address appear in a program section? How many times should? This is a question we've come back to. I hope you have programmed enough to realize that you should only use an output one time, unless you're using it as set reset, in which case you have to use it once for set, once for reset. How does the PLC interpret it? If it appears more than once, it's going to do the last thing it saw. So if you need multiple, you always have to do the OR. That seems to be a hang up for a lot of young programmers, is to realize that if I need it more than once, then I've got to OR all that logic together, and then it'll work just fine. What programming instruction is the exception to number 1 that you know of? And that would be set reset. So you would use the address twice, once for set, once for reset. What happens during a scan cycle? You scan your inputs, update your memory. You execute your logic based on your updated memory. Then you update your memory for outputs, and then you take your memory and you send it to the actual real world outputs, and then you repeat. We are going to discuss forces down here at the bottom, and so when you do your inputs, after doing your inputs, there is a force table. And so it can overwrite any inputs that it saw based on your force table. So you can force an input, then it will do its logic, and when it does its logic, it's calculating what output should be on. And then there's a force table for outputs where you can actually force an output either on or off and disregard the logic. So once you apply the output forces, then you would update the actual outputs. So there's actually two more parts to a typical PLC scan cycle, and that's when you deal with the forces. What controls whether a PLC will run its program scan? I think all of y'all have dealt with the stop and the run switch. And do all PLCs have this feature in some form? Most do actually have a switch. There are some that it is purely software controlled. So you can actually put your PLC in stop mode with your software without actually flipping the switch. So it allows you to do that, and some have a 3-position switch where you can force it into run, you can force it into stop, or you can leave it in remote and let the software decide where it is. In testing and verifying your timing counting programs, what can you do to accumulated values to expedite that process? So if you had a long stoplight cycle and you wanted it to test it to make sure your logic was right, what could you do? I think most of y'all have pulled up data view, and in data view you can actually go into the edit tab and you can actually write values. So you could write accumulated values to your timer to get them closer to their end. Same with counters, and we did that when we counted up and down. We actually put in some numbers in order to make things go faster. That's a good thing to remember in terms of getting programs to step logically, is if you just change an accumulated value in a timer or a counter, that's a little less intrusive than trying to go in and force logic to do something. And it's something you can do without a force, without anything, and you just write it, and the PLC just pretends like, okay, I'm here now. For 7 to 10, I wanted you to reload or rewrite your motor forward, motor stop start, forward reverse. So you have a forward control, a backwards control. And I wanted to see if you could control the motors with input forcing only. So in other words, force your switch on, force your switch off, and then see if it's possible just using input forces to have both motors run. Now, some of you don't have a PLC, so you're going to have to take my word for it. You should not be able to get both of your motors running just using input forces, because input forces come before the actual logic in the program. So if you've got your logic in the program interlocked so that you can't have those two outputs on at the same time, then you will see that it's impossible to control your motor, to have both motors running with input forces. Now, the output force table is on the other side of the logic, so you can, using output forces, actually force both your motor outputs on. And I do this program to let you see that where the forces are acted and where they go in the program scanned. So you can ignore the logic and tell both your outputs to be on for both motor forward and motor control. Of course, you'd never really want to do that. And I tend to be of the position where you should not use a force. My background has been around equipment with people running, so the danger I see with input forces is an operator's used to pushing a button and the machine stops. Well, if you force that button in such a way that it no longer works when the operator presses it, you are creating a potential safety issue. So I would not do it. And of course, output forces, you can actually destroy quite a lot if you're not really sure. The only example or exception to that rule is if you are troubleshooting a program and you don't have real I/O attached, so you don't have a push button out there to push because it's not been wired up yet, then forcing makes sense there as far as proving a program and improving your logic. And it's also helpful in looking at student projects to make them work. Okay, what does the click output copy do? And what is similar in Allen Bradley? And then what happens with a mask? Okay, so I want to go to a couple of video slides. I'm going to show you the copy instruction. Okay. What a copy instruction does is it will copy from one part of your program to another part of your program. What is similar in Allen Bradley is the move instruction. So you can move data from one part of your program to another part of your program. Now, when you first hear that thought, you think, well, that's silly. Why would you ever want to do that? If you've already got it where you want it, why would you want to move it or copy it? But what you'll see in the next program we do is that it is useful. Okay? And then the other concept that comes up is something called a mask. Click does not really talk about mask in their manuals. I haven't seen it, but you can sort of do masking. What masking means is, now I'll go to that slide, is, and I've set this up for worksheet 19. Just ignore that it says 18 up there because this is for worksheet 19. I'll make a video for it. These are my outputs for my lights. Okay. And so when I want red on, I want 13 and 10 to be on. I want 15, 14, 12, 11 off. Now we did binary, and if I make this my least significant bit, and I Scroll over, that's a 1, 2, 4, and an 8. So 8 plus 1 is a 9. So that's my number, if you will. So in DS10, I can put the number 9, and then I can copy it into these outputs. Okay, so what it'll do is it'll take a number, it'll convert it to the binary bits, and it will write it to the outputs. And when you're moving in Allen Bradley, you're actually moving a number to an output, and then the output card does all this breaking down that I had to set up for in the click. So it's a little more powerful in the Allen Bradley. Now what a mask does is, a mask is something where I AND with either a 1 or a 0. So I'm going to take C10 for instance, I'm going to AND it with a 1 or a 0. If I AND it with a 1, then I get whatever C10 is. If I AND it with a 0, then I get a 0. So your mask goes through here, and all these bits you can actually mask out the ones you don't want to have affected by the move instruction. And that's in Allen Bradley. In Click, you really don't have that option. We can just limit our outputs, and we can limit the way we move things. So there is a mask sorta, because we're choosing the outputs that we're writing to. But in Allen Bradley, if you think about it, if I've got 16 bits in a word and I write it to another word, but I only want to use these 5 or these 6, I mask out everything above C15. So then when I write from word to word, I'm only going to get these 6 bits affected. Everything else I will AND with a 0, and nothing will happen. So then I can use other logic for, say, C16, 17, and 18 later in other places of my program and not lose it. So that's why with the move you sort of have to have a mask, and with the copy you don't. Okay, and you can read about copy. Matter of fact, I suggest you do. Okay, what is a mask? In Allen Bradley term, just click how that functionality, how's it really implemented. And basically a mask is a digital ANDing with either a 1 or a 0 from your data that you're moving or copying. What logical operation happens when something has a mask applied to it? You are ANDing, as I have said. What mask would be used with a copy or move statement to not affect other logic controlling bits 2, 4, and 5? So if I start with bit 0, I want to write bit 0, 1, 2, 3, 4, 5. I think I can go back to this. Okay, so I don't want to change anything that's in 2, 4, or 5. Is that what it said? Yeah, 2, 4, and 5. Okay, so what I would do is I would create a mask 2, 4, 5 where these are 0s. Everything else would be a 1. So if I take off a word, and we'll just use an 8-bit word because that would be 6, 7, and 8 out here. Then if I make these all 1s and I subtract off 1, 2, 4, 8, 16, so that's 20 and 32, and I subtract 52 off that number, then what's going to happen is anything that's going to C12, 14, or 15 will not happen because I'm masking it out in Allen Bradley. In Click, I just choose what outputs I'm going to copy to. It's a little easier, a little more straightforward. But Allen Bradley does have that mask, and it's something you really got to work with some, and I'm just trying to introduce you to it and get you to where you when you see a mask, you sort of know what's happening there. Usually your masks are set at all Fs, which in hexadecimal, a hex is a 1 in every bit position. So it's 16 bits and every bit's a 1. So basically, if your mask is set to Fs, you're not masking. If your mask is set to 0, you're masking everything. And so there's some number between all and nothing, and you can individually pick which bits you ignore. I know that was a lot. I know. Okay. Can the click instruction be masked? See the unpack copy in help. So in my slides here, I've got an unpack copy. There it is. Instruction. And you'll see this again in my next video. But here's my copy options. I can single copy, so that would be from bit to bit. I can pack copy, so I can take bits and I can turn them into a word. I can copy blocks, so I can copy from C values to C values, or I can copy from a word to a series of bits, and I can take one and I can fill. So DS11 is a word. It's an integer. It's either 16 or 32 bits. I think it's 16 bits. And so what I'm doing is I'm taking whatever value I've got in DS11 and I'm copying it to C10 to C15, which is only 6 bits. So even though I've got a 16-bit word up here, I'm only going to use the first 6. So in other words, I'm masking out the last 10. So I can have anything in that word, but I'm only going to use the lower 6 bits when I copy. So I am sort of applying a mask, even though it's not called that. Okay. There we go. That should help you with worksheet 18, which is pretty easy. There's no program to write, and if you do have a program and you do have a PLC, you can play with the forces. If not, just give me my answers. Give me your best answers. Anyway, thanks for watching.